Okay, welcome to Chapter 11, Section 1, which is on conic sections. And let's just talk about it briefly, and then I'm going to go into parabolas. Conic sections are formed by the intersection of a double cone and a plane. Standard conic sections are circles, parabolas, ellipses, and hyperbolas. And let's look at a diagram, but they are formed when the plane does not intersect the vertex of the cone. You also get things called degenerate conics, which we're really not going to talk about, but these are points, lines, and pair of intersecting lines. Okay, so we're going to learn later on that this is the general form that we'll be looking at. In fact, we'll do some examples of this with each of the parabola, ellipse, and hyperbola in the future. And here's our main diagram, and this is in the conic section notes PDF. And you can see you have a pair of cones meeting at a vertex. And in the first case, if the plane that you cut the cones with is perpendicular rather to the vertical cone axis, you get a circle. If it's tilted in the second case, you get an ellipse. If it's parallel to a side or edge of the cone, then you get parabola. And the last case, you can see you get a hyperbola. You can see the two wings of the hyperbola. All right, so I'm not going to talk much about these, but just keep in mind that if the plane intersects the vertex or the vertices where the cones meet, then you get the degenerate conics, point, line, pair of lines. Okay, begin with a circle, which we're really not going to do much with for the simple reason that we've dealt with circles in the past, but I'll start anyway. We have a locus definition. Locus is a phrase from the Latin, has to do with location. Circle is defined as the location or the locus of points, x, y, fixed distance, which we call a radius, from a fixed given point, which we call a center. And basically, we just use the distance formula, and there we go. You get this from the distance formula. And squaring, you get the standard form of a circle where HK is the center and R is the radius. And of course, if you expand it out, you get something called general form. And we're going to have to be able to go from this form to the standard form and vice versa. And we'll practice all this stuff with the other conics. Okay, first one I want to get to is the parabola. And the definition, the locus definition is it's a location or the locus of points, x, y, which are equidistant from a fixed point. This fixed point is called the focus, and a given fixed line, and a fixed line is called the directrix. Okay, so you got a point here, which is the vertex. It's a distance p from the focus and also perpendicular distance p from the directrix. And as we move out along the curve, okay, let's pick an arbitrary point P. This length, FP, is the same as the distance from P to the directrix. Okay, so this distance we get from the distance formula, right? It's going to be y minus p quantity squared, x minus 0 quantity squared under radical. And since this is a perpendicular always, we're just going to get y minus or minus p, or as you'll see, y plus p. So we get that these distances in blue are equal. And this, of course, we have different views of this. This we'll call the concave up view. Okay, so we put in our formula here, and this is the equation which we're going to solve. And of course, we got to square both sides. Square of the left side is x squared, and this, of course, is a binomial, so you get y squared minus 2py plus p squared. And on the right side, we square the binomial as well. Y squared plus 2py equals p squared, and you get a lot of canceling. So the p squareds cancel on both sides. and the y squareds cancel on both sides. We move this term over, so we get x squared is 4py. So this is the general form of the up or the concave up case of the parabola with the vertex at 0, 0. Okay, the more general form with the vertex at hk, we just substitute x minus h in place of x and y minus k in place of y. This is the general form. Okay, and as you can see, there are other general forms depending on the orientation. So notice that the forms with the x term squared are the up and the down type. And at the up type, you have a 4p. With the down type, you have a negative 4p. All right, so one of the things we're going to have to do is just identify, is it up, down, or is it left, right? Okay, now you can have the left, right versions, in which case those are the y term squared versions. And opening right, you got a positive here. Opening left, you got a negative. All right, so those are the four versions. And just to run through this quickly, a lot of applications in science have a parabolic reflector. You even have flashlights now where the bulb is located at the focus and the beam comes out parallel. So these are different types of orientations. And, we're going back a few words you need to know. You got the focus, you got the vertex, you have the directrix. Okay. Couple of these terminology here. Latus rectum. Okay, lattice means side, or rectum means straight. So latus rectum is a line which runs through the focus and is perpendicular to the main axis. Okay, so this length is 4p, and you can easily get that if you just go into here and you substitute in coordinates of this point, which would be let's say x comma p, right? Because the x value is x value and the height is p, and put this in, and you'll find that this length is 2p, so the whole thing is 4p. You can write that out for yourselves if you want. We're also going to hear a phrase later called the eccentricity, and that has to do with how much a parabola is squished. And it turns out that it's a measure of the ratio of this length to this length, and since they're equal in a parabola, eccentricity of a parabola is a 1. We'll see that how that plays in more importantly with ellipses and hyperbolas later. Right now, all I want to do with parabolas, and we're going to pause this now, and then we're going to go and do some examples on the whiteboard. So hold on while we pause this. Okay, here we are back, folks. This time I'm using the whiteboard again. Haven't used that in a while. We'll see how things work out. What we're doing here is we're looking at example number 2 from writing the equation of a parabola. It's one of our worksheets, which is listed on the blackboard. And we have a parabola which is concave down. So it's going to be of the x squared type. So it's x minus h quantity squared and y minus k. And notice that you have a negative here because it is concave down. And what we're going to be doing here is we're going to be trying to come up with the equation and answer some questions about it, such as the vertex and the focus and p and latus rectum and directrix and all of that. So here we go. First thing is to notice that we know what the vertex is. So h is 1, k is 2. So we now know we have h minus 1 quantity squared, negative 4p y minus k, so that becomes a y minus 2. Okay, so moving along here, the next thing to do is to try to find P. See, this isn't fully determined yet. We want to find P. Okay, so let me just pause this for a moment. Okay, we're back. I had a little bit of glare on the board. Let's see if I can fix that a little bit. All right, so try and get rid of the glare as much as I can. But okay, so here we are. Let's try to find P. Now, in order to do that, we need another point on the curve. And we know a point on the curve is 2, 1. So when x is 2, y is a 1. And we get, this is 1. 1 squared is 1. This is a negative 1, so this becomes 4p. So we instantly get p equals 1/4. Okay, so this is going to be one of the things that we'll be asked to generally find. So we know p is 1/4, and we also know now, if p is 1/4, that we know for sure our equation is 4 times 1/4 is 1, so that's a negative. So we know for sure now this is our specific equation. P is 1/4. So let's talk about other things we have to find. Well, we're expected to find the vertex. So we should be able to just look at this diagram. We knew that originally. The vertex is 1, 2. That's easy enough. Let's get the focus. And the focus, of course, is going to be a point in here. Okay? And the value of P tells us how far we have to go. So we're going to go one step down, so that will give us the point. Well, let me label this V for vertex. So the focus, therefore, still going to have an x value 1, but it's going to be down 1/4 because that value is P. The distance between the vertex and the focus is P. So 2 minus 1/4, 1 3/4. So the focus would be the point 1, 1 3/4. Okay, so that's another thing we need to find. And another thing would be the directrix. Now the directrix is a line outside the parabola, which is perpendicular to the axis of the parabola, and it's p units in the other direction. So, well, let's see. This is going to be the line y equals something because all the y values are the same. If it's going up 1/4, it'll be y equals 2 1/4. Okay, so the directrix, in this case a horizontal line, y equals 2 1/4. Okay, and the last thing we often ask to find is the length of the lattice rectum. Okay, so the lattice rectum is perpendicular to the axis of the parabola, goes through the focus, and it's the length here. And you can compute that by plugging the numbers in, but we have a little formula for that. And the formula is the lattice rectum and length is 4p. So in this case, if p is 1/4, 4 times 1/4 is a 1. So the length of the lattice rectum is a 1. Okay, so let me pause this. We're going to do another example. Give me time to erase the board, clean it up. Hold on. Okay, next example, welcome back, is number 7 on that sheet, conic sections. And again, looks like this. And what we're doing is we're given a graph or sketch of a parabola, and we are asked to compute its standard formula and find its vertex and focus and P and lattice rectum and all of that stuff, directrix. Okay, so we're going to notice this is a sideways type, so it's going to be the y, which is squared. Okay, so it's going to be y minus k, the quantity squared, is 4p x minus h. So we have to recognize this is a left-right type, opening right, a concave right, so we have a positive right here. Okay, and from the diagram, The HK is negative 2 comma 0, so we immediately know that the vertex is negative 2 comma 0. This is our H, this is our K. I'm going to plug them in. So you get y minus 0 squared is y squared, and x minus h minus a negative 2 is a plus 2. So we're not quite there yet. Now we have to find p, but this is how we proceed. We write the formula, we start plugging in. All right, so we've used this fact that goes through negative 2, 0. We use another fact that's through the point 0, 1. So when y equals 1, you get 1 squared here, right? X equals 0, so you get 4p times this. So that works out 1 equals, this is just 8p. So therefore, p, whiteboards, equals 1/8. Okay, so we've computed and we found p. All right, so let's see. One of the things we had to get was the vertex. Another thing we had to get was p. Oh, so let's write the actual formula then. Okay. So you got 4p. 4 times an eighth is 4/8. So you get y squared is 1/2 x plus 2. And this would be the formula for that specific parabola. And then a few other things we had to get. We had to get the focus. So the focus we know is p units inside. So let's see. If x, well, the y is not going to be changed, so the x, we're coming in 1/8 of a unit this way, so to be negative 1 7/8 would be the coordinates of the focus. So let me write it down here. Focus would be negative 1 7/8, comma 0. So that would be the coordinates of the focus. Okay, and that's not so bad. Okay, and then what else do we want? Well, we usually want the directrix. So the directrix, in this case, is a line perpendicular to the axis of the parabola, but outside the parabola. So if p is a 1/8, see, to get the focus, I counted from the vertex this way to get the focus. To get the directrix, I go the other direction. So if I'm starting at negative 2 comma 0, going an extra 1/8 out, then the directrix, okay, has the formula. Well, in this case, it's a vertical line, so x equals negative 2 1/8. Okay, and all of this is worked out in detail for each of the 8 problems on this worksheet, and it's on Blackboard. So you should work this out for yourself and, verify that that you understand this. Okay, the last thing we typically do is the length of the lattice rectum. Okay, so the lattice rectum goes through the focus perpendicular to the main axis, and what we're looking for is this length. Okay, so we're supposed to know in a parabola it's 4p. Since p is 1/8, you get 4 times 1/8. So the length of the lattice rectum is 1/2 unit. Okay, so that would finish up with what I wanted to do. We're going to come back in a new video and we're going to take some problems out of section 11.2 of the textbook.